Good afternoon and welcome to today's T&D World webinar. Today we're covering how PG&E designs and builds a more sustainable, resilient, and affordable grid. We're sponsored by Power Delivery Intelligence Initiative and Pacific Gas and Electric. I'm Nikki Chandler, Market Content Director for T&D World. To begin, let me explain how you can participate in the session today. First, if you have any technical difficulties during the session, just please submit that to the questions window there, and our technical experts will help you out. We do recommend disabling any pop-up blocking software or extensions in your browser, as those can sometimes cause issues with the webinar player. Additionally, we do welcome your questions during the event today. We'll answer as many questions as possible throughout the event and then at the end, but send those questions in at any time throughout the session. To do so, simply type the questions into the question window on the side of your screen and hit submit. To refer a colleague to today's discussion, you can share it on social media or access event resources and click the icons on the left side of your screen there. One tip, to resize your windows for a better view, you can click on the upper right-hand corner to enlarge those on your screen. Also, please be aware that today's session is being recorded and will be available on the T&D World website within the next 24 hours. You'll be notified by email when that archive is available. Now, I would like to hand things over to Mike Beehler. Mike is the national spokesperson for PDI Squared and a regular contributor to T&D World. So I'll go ahead and let Mike introduce our main guest, and just go ahead and take it away, Mike. Thanks.
Will do, Nikki. Thank you very much, and it's a great day to be with you all. And I just want to tell you, who is the Power Delivery Intelligence Initiative? We're a group of contractors and consultants and cable manufacturers and equipment manufacturers that advocate for underground versus overhead electric transmission and distribution, mostly distribution. And we encourage planners and engineers and even today data scientists to start to look at the total cost of ownership of the asset, of the T&D asset over the life of the asset, total cost of ownership over the life of the asset, believing that ultimately that is going to make a more sustainable and reliable or / resilient and affordable grid. And that is exactly what we're going to talk about today with our guest, Shawn Adderly from Pacific Gas and Electric. Shawn, we're so thrilled to have you. Have a quick hello from Shawn Adderly.
Hey, thanks, Mike. Glad to be here. Look forward to today's discussion.
Well, Shawn, I've looked at your slides. You've got some rich content. We're going to let you go through about 20 slides here. There's going to be an opportunity for some discussion. Nikki told you if you've got some questions, go ahead and send them in. When we get to about 15 or 20 minutes left, we'll do the Q&A from the audience. I may interject some questions as we go, Shawn, as you know. But great content here, even getting into the AI-enabled utilities. So I am really excited, and I'm sure our listeners are really excited to learn about what Pacific Gas and Electric is doing. So with that, Shawn Adderly, take it away.
Hey, thanks, Mike. Appreciate it. So today we're going to be talking about building a sustainable, resilient, and affordable grid. And as you'd imagine, it's really hard to balance all three of those things, particularly with rising costs of materials, customer affordability concerns, time to market, interconnection times. So it's a bit of a conundrum that we're certainly facing as industry over the next couple of years to figure out how to do this in a way that works for everyone and also balances a lot of our key initiatives and goals. So just a little bit about PG&E. So we serve about 16 million customers across a 70,000 square mile service territory. So one of the largest combined single electric and gas utilities in the country. And we're really facing, I think, along with the rest of our peers in the utility industry, a once-in-a-generation transformation. And we'd like to believe that we're going to be, a key leader in that transformation. So over the next couple of years, we're really looking at large increases in peak demand growth, driven by electrification, data centers, just continued growth of, the country, And at the same time, we're trying to also make sure that our customer bills don't increase, more than the rate of inflation, right? So the goal is to keep that matching with inflation or under inflation, which is also another challenge, right? So really, as you can see, we do have to make some large investments to meet our goals, particularly with the increase in load coming. So the question is not really, whether we need to invest, but it's how we're going to invest and how we're going to keep, energy affordable for every customer. So it's really a unique challenge, and I'm really excited to partner with many folks on this call and other facets of the industry and outside of our industry, and trying to figure out how to live up to the moment and making the best out of the moment that we're in right now to meet these unique challenges. So really looking at grid transformation, there's really three key pillars. So in California, we definitely want a sustainable grid. That means that we have clean energy that's integrated, we're doing electrification at scale, and we're moving towards a path to net zero. So those are, some of our, key tenets when it comes to sustainability. But at the same time, we need to make sure that we have a resilient grid where we don't have wildfire risk. We are, hardening and increasing reliability through different methods, whether it be undergrounding or microgrids, and then also looking at the latest and greatest in technology when it comes to monitoring our equipment, making sure that we can identify, issues before they occur, and really allowing us to build a workforce of the future. And so that all has to be done at an affordable basis as well, because our customers expect us to use, our ratepayer money well, and also balance, their needs as well as the larger needs of the grid. So when we look at trying to make this affordable, we're really looking at in the lens of total cost of ownership, really trying to make sure that we're capturing, the full end-to-end costs, and we'll talk more about that during this presentation. Looking at different ways to reduce our operating costs, making things more efficient, leveraging AI, doing things that we think are going to lead to, better bottom lines for everyone. And then also looking at just how we can take advantage of this beneficial load that we're going to see coming onto the system. That's really going to be able to lower our bills. So I think one thing that we'll definitely be thinking about right over the next couple of years is, well, which pillar is the most important investment focus? And really all of these, right? So all of these pillars are important to us, and they're important to, the ecosystem of our energy grid. So we're really looking at, how do you create the best integrated strategy and not really have, separate initiatives, because all three of these have to be true, not just one.
Well, okay, so Shawn, you tempt me when you say you've got a discussion question there, and I just have got to jump in here and say I have an opinion about this, is about where would you invest in the next 5 years? What, as we're trying to achieve these three specific goals, what synergistically accomplishes it all? And so I start to think of things like, I think naturally of underground. I think underground is more sustainable in the way it treats cradle to grave issues regarding the environment, definitely more resilient with regard to wildfires, ice storms, and hurricanes and derechos, etc. And then affordable when you look at the total cost of ownership over the life of the asset, especially looking at what you might have to do to recover from a high impact but low probability event. Underground just makes total sense. And if we also factor in the lost GDP, gross domestic product, of a region that loses power for a day or 3 days because of a major event like a wildfire or earthquake or whatever the major high impact, low probability event would be, again, underground makes a lot of sense. So that is my biased opinion. Shawn, what other kinds of things are you thinking about at PG&E? You have a huge underground initiative, obviously. Is there something else that you're thinking about at PG&E as well?
No,
maybe something on your overhead system?
Yeah, no, I think, Mike, you hit it on the nail on the head. So, I mean, I think the total cost of ownership, definitely with undergrounding, especially when it comes into play in California, which has high wildfire risk, large amounts of vegetation management, definitely, right, you can see benefits from the reduced cost of, doing veg management over time, the reduced costs of, customer outages and value of service impacts. So, you're spot on there. But yeah, other things I think that comes to mind is just, looking at how to operate the grid more efficiently. So, over the next couple of years, a lot of utilities are either already, in the middle of it, or they're working through it in terms of upgrading their ADMS system, their EMS systems, their energy management system, really to provide other capabilities that we didn't have in the past, like dynamic line ratings, to be able to really re-rate our lines in real time during the day based on factors like temperature and load, and sagging, and just being able to operate the system a little bit differently. And I think particularly on the distribution side, we're going to see more of a sectionalized system that's going to be hopefully more efficient to operate, while we are able to take advantage of DERs and other things. So I think those are things that are going to really make a difference in the next couple of years.
Great, thank you.
So, as I mentioned before, the grid is transforming more than ever, right? We're definitely living through one of the largest grid transformations since the post-World War II era. And people always, ask, like, well, why do you anchor on World War II? Well, a lot of people came back from World War II. They went into a variety of different jobs. You have, a large growth in suburbs. So you had a massive build in terms of our distribution and transmission network that occurred, and that was unprecedented. And we've been living with that network for the last couple decades, right? So since then, and really now there's a sort of a step up where now we're seeing new growth, right? That's coming on the system in the form of data centers, EVs, other electrification. That's really going to force us to transform the grid again. So when we think about the grid of yesterday, it was one-way power flow. You go from the generation to the customer. Now there's bidirectional power flow. You can be a small generator if you have solar on your house and send back that to the grid, and potentially get a net metering benefit from it. We also see a lot of large customers also creating their own solar, wind installations, also providing bidirectional flow. So that's definitely a big pivot change. We're also seeing, obviously, in that same vein, we're moving from centralized generation to distributed generation storage. We're also moving from manual inspections to more AI-powered monitoring. And so, we're now seeing things like, the robot dogs, if you've seen those at different conferences, working their way through substations and doing temperature readings, looking at the fence, making sure that no one's intruded, looking at drones flying over the substation, every couple of days or every day to actually assess the condition of assets. And so we're really seeing a pivot in our workforce when it comes to that. So that's going to be a huge transformational change. And I think one of the things about that is, like, hopefully we're going to see more people that are getting skilled up in these jobs, enjoying the utility, and helping pair with the current expert knowledge that we have in our linemen and our electricians and all the other folks that we have, our union partners, to help us leverage that technology to make us more efficient and allow us to get our interconnections faster, allow us to reduce the amount of time that we're doing on inspections and spend more time on customer connections. So similarly, right, we're looking at getting away from more reactive maintenance and moving to more predictive maintenance. There's a lot of progress has been made in this area in the utility space in the last decade, and we continue to build on that and see that sort of permeate across the industry, as well as other industries too that are also using that in their manufacturing facilities and other industrial industries. Also, this is going to be the time where we're seeing that in the past, when I grew up, believe it or not, I actually still had a meter that was not read by Wi-Fi or a mesh network meter. So you actually had the meter person come in, go into your gate, look at the meter, get a reading. Obviously now we have smart meters. PG&E is one of the largest smart meter networks in the country. But beyond just smart meters, right? It's about getting intelligent information about how we can better operate the grid. And I think we're just going to keep, moving far in that direction. That's really help us to operate our system. So, as I mentioned, right, there's many driving forces that we're seeing in the grid of the future. Electrification, huge. Data centers and AI, huge. One of the things that you'll probably hear from NVIDIA's CEO, he's been very vocal that one of the number one jobs out there that he believes is being an electrician, right? He sees tremendous growth in demand in that industry, especially to keep up with the power intensive, computational intensive, data centers that, run many of the AI tools that you and I are using today, whether it be internally or externally. And then, we're continuing to see growth on rooftop solar and storage. EVs are going to continue to grow. And then really we have to make sure that we're building a system that's resilient for climate. And what I mean by that is that, we're continuing to see extreme weather events. We're definitely still in a high wildfire risk area, but we've done a lot to mitigate that. So really, I think the takeaway here is that we're really seeing every aspect of the grid changing simultaneously. So you have to manage a lot of things at one time, and a lot of things are true.
Shawn, there's so much rich content on that slide. Let's go back to that slide just briefly. And you said since World War II, that's actually 2 or 3 generations of men and women in the industry. And so speak to the young engineer, that is under 30 in our industry today, that is working on a system that's 2 or 3 generations old, but now has this pivotal point in time when we must move to these emerging technologies. You talked about robots, you talked about unmanned aerial vehicles, you talked about predictive maintenance and artificial intelligence and such. With a good shout out to craft labor, though, I do appreciate that. And what do you say to the young engineers, the men and women that are coming up, the under 30, they're planners, they're engineers, maybe they're data scientists, and do they get pushback anymore on, no, we can't do it that way, it's never been done that way before, no, we got these standards? I mean, what do you think's happening? What do you sense at PG&E?
Yeah, so I think we're fortunate, actually, not to toot our own horn, but I think we're known as an industry leader in adopting a lot of new technologies. So, we have like an EPIC project program, which, basically funds like emerging things that we can test out. So, I was definitely that young engineer when I came into PG&E over a decade ago after working at IBM, and, was one of the first data scientists in the company. And it was a little bit challenging at the time, right, to get people sort of bought into some of the data models, the predictive modeling. But I think that the key behind it, right, is that you really have to be able to back up what you say you can do, right? So if you can really prove that this is going to be better, I think you're going to be allowed the space and opportunity to do that. But it's not going to be, hey, just take it on faith, it's going to be better. You're really going to have to sit down and explain it to some of our folks, here and other places, right, who are been in the industry for 30, 40 years and are like the top end experts, right? So you're going to have to do a lot of work in being able to make sure that you can have a defendable position that makes sense, and that people can actually get behind what you're proposing. And I think we're seeing that slowly in our industry as a whole, right? We're seeing the adoption of new technologies at a rapid rate, and we're winning over a lot of the folks who were once skeptical with some of these new technologies.
Yeah, actually, very well said, Shawn. Very well said. Question from the audience. Big public power utility out west is saying, your mitigation strategies and strategies just in general, are they that much different for transmission than they are for distribution, or do you have some core principles that apply both to both parts of the T&D system?
Yeah, I think that we try to be as consistent as we can when it comes to like thinking about it from the same framework of total cost of ownership. I mean, obviously there's some different considerations when it comes to the rate case, when it comes to our transmission system versus our distribution system, but we're still focused on the same things, making sure that we have adequate capacity, that we have a really good maintenance plan, that we have a skilled workforce that's working on both systems and gets cross training on both systems. We're making sure that we're adopting, new technologies when it comes to sensors and monitoring on both the T&D system, and we're just making sure that we're just managing the resiliency on both systems as best as we can. So yeah, not too much differences other than really the rate gate structure sort of application.
Good. Thank you.
All right. Okay. So as I mentioned before, right, it's really true, right? The affordability challenge is true. We're trying to, manage rising infrastructure costs. I mean, particularly after COVID and some of the larger inflation rates that have come through, the cost of materials, labor, and other things have increased, right? So we have to make sure that we're balancing that against our customer affordability. Similar, we're seeing surging demand, and we have to make sure that we're able to build out our system as fast as we can, but also manage our customer affordability. We're seeing that we're getting, pushed by our regulators and pushing ourselves to make sure that we're moving towards our net zero goals here in California, but also doing that, with cost pressures and trying to maintain affordability. And then same thing with wildfire and climate adaptation. We're trying to make sure that we're hardening our system, but doing that with affordability in mind. So there's really this tension that's going to be here, I think, for a long time in terms of looking at investment and affordability. But I think that, really the key thing behind this is just making sure that we're looking, down the road in the long term. And I think, my next slide is going to sort of touch on that when it comes to total cost of ownership. So really, I think, a lot of our decisions in the past have been based on the upfront capital costs, but we really need to look at the full picture over the life of an asset. So, really, we have to think about the maintenance costs that we're going to have. Every single, above ground pole, for example, you have to do test and treat. You have to check the condition of the pole. You have to check the condition of the transformer on the top of the pole, the cross arm. And so there's things that, have to be inspected over time. And so you have to understand like how those costs are going to increase when it comes to labor, inspection, criteria is changing and other things. And so that's definitely something that you need to take into account when you're looking at the total life cycle. We need to think about our outage cost to customers, particularly when it comes to value of service calculations and looking at the impact of power outages to customers. And really, I think this is even more important than it has been in the past because, for most of my career, I've gone to an office every single day. And then, obviously COVID came around and a lot of remote work came into play and a lot of remote work stayed on a hybrid or permanent basis for many. So power outages, impact customers even more at home than they used to. So it's not about, just losing the food in your fridge and nobody's home during the day. It's also like people are now working at home. People are, I have a nanny share at my house with my daughter and another child in the neighborhood. And so we definitely need our power during the daytime and we need it at home. So I think there's this new added factor of ensuring reliability at an even higher level, right, for not just our industrial and commercial customers, but also, paying attention to the cost impacts now to our residential customers, looking at the wildfire exposure. So certainly making sure that, we're minimizing our risk and exposure, really looking at, how this is going to impact our workforce over time, and then making sure that we're valuing the opportunity costs. So really need to look at everything from a total cost of ownership and making sure that we can manage that. And I think when you do that, sometimes you can see we can reduce costs up to 40%. So it's important to look at the long term. So that's really the punchline there.
Yeah, I love the idea of the opportunity cost of not future proofing. I would change that to say that we need to position for the future. We don't know what the future is going to hold, but we know that, we could wake up tomorrow and there could be a break in material science that would change the whole nature of battery storage. or that would affect electric vehicles and large-scale storage. We could wake up tomorrow and there'd be just a game-changing technology that would come onto the forefront. And how are we positioning for those kinds of opportunities on the grid today? And it's not by building out of a standards book that was done in the 70s and the 80s and the 90s. It's about looking at these new technologies and positioning for the future. So future proofing, I like future positioning for the future.
Yeah, I like that too. I'm gonna have to modify that to update that.
Well,
good call out. Okay. So I think, Mike touched on this and we touched on this at the beginning. So obviously, I think everyone's familiar that PG&E is going through one of the largest undergrounding efforts in the United States. And, we've seen a lot of benefit from this so far in terms of 98% reduction in, ignition risk removed permanently. Previously, we had a lot of large proactive power shutoff events as a result of trying to minimize the risk from our assets being involved in an ignition event. And, we've seen those events go down in frequency and size dramatically, right? With undergrounding, we've seen dramatic reduction in tree trimming costs. We've seen dramatic reduction in our emergency response costs. And we're really looking at, increasing our asset lifetime as a result of that. And we're seeing, great reduction in distribution or disruption from our other things like high winds or fire or vegetation getting into our lines. So it's really definitely something that we've seen in action here when it comes to undergrounding from a total cost of ownership perspective. Okay, so I want to touch on AI a little bit, and these are just some high-level thoughts on how I think potentially AI will manifest itself inside the utility industry. I think that we've seen a lot of different thoughts on AI, and probably every single day someone has a new thought about what it's going to do or not do. And I think those things are still evolving, right? But from my perspective, I think that we do have the opportunity to lower the cost of operations and maintain the grid with leveraging AI and other technologies. So I think when we start looking at technologies that help us with dynamic line ratings and optimized load, we can really hopefully manage our ability to reduce our need to potentially lines. We sort of refer to this as like non-wire alternatives, and so I think that I started thinking about all of our feeders that people are getting battery storage and solar combined, and staying within one transformer per couple houses, and you can hopefully redeploy that without having to upscale the capacity. I mean, over time across the industry, I mean, that's probably billions of dollars. Similarly, right, I think we're going to see millions of dollars in operating costs annually when it comes to leveraging technology to do the inspections faster, automate them. I think one of the things I like to use as an example is that I go to our grid control center up in Vacaville quite often. That's run by our Vice President of System Operations, Rod Robinson. And there's photos on the wall of what the grid control center and the distribution control centers looked like 40 years ago. And there were 40, 50, 60, 100 people in some of those rooms looking at screens and operating our system. When you go in, there's a dozen people that operate the transmission system in Northern California when it comes to PG&E, and that's really driven by automation, right? And really reducing a lot of manual processes, and we're seeing the system really contingencies in real time and aiding the operator. So I would argue that we've seen some of that reduction, and we're going to continue to see more reduction in costs, being able to automate more things. And then when it comes to the other benefit, right, for our end customers, it's really about reduced hours of avoided outages, right? So I think that we're going to see less outages over time when it comes to having better sensors that give us more visibility to our system, whether it be current sensors or accelerometers that look at movement of our lines so that we can pinpoint assets that might have been impacted by a seismic event or someone hitting the pole with a car, and being able to now know if a pole to the left or to the right was impacted by looking at some of the accelerometer sensors, looking at technologies to do non-intrusive pole inspections quicker. So I think there's going to be dramatic benefit here. And I really am curious to hear from folks to think about, like, what do they see is going to be the single best impact that from AI that's going to really reduce our customer costs, because every dollar that we save, right, is a dollar that gets not passed on to our customers. And so that's really what our goal and mission is as a utility. And so I think I've already touched on these in terms of just ways that I see AI potentially reducing customer bills and automating things. So I won't get into it too much here. Some of the ones that I've already mentioned, right? I mean, PG&E, we have a large service territory at the beginning of the call that I 70,000 square miles. So, really got AI cameras looking at different parts of the service territory to understand, whether there's ignitions about to occur, looking at the weather conditions, looking at other autonomous detection of things when it comes to physical security and other things. We're really leading in on drone inspections for our towers, for our substations, and for other distribution assets as well, like pole tops. And then, really leading in as well and trying to improve our customer experience when it comes to notifications of outage alerts, personalized energy advice, and other things. So there's a lot of improvements that we're seeing in the call center space, a lot of improvements that we're seeing in the PG&E website and other things that's going to help our customers, get information about their rate plans faster. We're definitely leveraging AI when it comes to looking at grid planning. So really trying to understand where we're going to see growth next, and really trying to, help that inform building out our system where we're optimizing it, not overbuilding, not underbuilding. Really, looking at the next generation of asset intelligence when it comes to digital substations, right? So we're moving away from most of our, copper control wires to, fiber optics, looking at, advanced conductors, so that we can, really understand, where there's a break in the line faster when it comes to, outage identification and monitoring, and just looking at load optimization as well. So just figuring out how we're going to be balancing our system better on both the distribution and transmission side. So huge application for AI across the grid. And I think these ones are actually tangible. So I think folks, sometimes talk about pie in the sky ideas, and I think all of these are actually tangible. So I don't think these are not doable. So I do think that we're going to see these ones really make a difference in the next couple of years, and they're already making a difference now in many of our companies.
Yeah. So Shawn, I think all of these are great ideas. And aside from what you do with customers, I think there's lots of businesses around the country and world that are doing things with customers. But we have a very unique electrical system that is the foundation for everything else that we do in this country / the world. But these are really good applications for AI. So I'm going to ask you a two-tiered question. One of your previous discussion questions was, in the next 3 years, which one makes the most sense? So Shawn Adderly, what one is your favorite? And the other part of the question comes from a big Western IOU that asked, this person at this IOU asked, what kinds of loads, what are these electrical loads, and do we need to modify our systems today for the electrical loads, these changing new technologies of electrical loads that are coming? And I would say that in the context of these data centers. So if you're going to go serve a data center, do they have some expectation that you are going to use AI, which is basically what they do, to better run the system that serves them? So it's kind of a two-tiered question. Do new loads like data centers expect you to use AI, and what do you think in the next 3 years will be the big item on artificial intelligence that really moves the needle for us?
Yeah, no, that's a good question.
There's
I
a
mean,
lot
I
there.
really think, yeah, no, I really think it's gonna be, for me. I mean, I think I like the drone inspections and I like the autonomous inspections, because when you look at something like PG&E's service territory, and we have north of 2.4 plus potentially million distribution poles. We have 50,000 plus transmission towers, poles slash other transmission structures. We have nearly 1,000 substations. So I think that that's going to be one of the greatest things that's going to see a large impact, because it's really going to take less time to do those inspections, and that's less time that we have to send linemen and electricians out to do those inspections, and those folks can now focus on actually building out our grid, right, or replacing
Right.
deteriorated conductors. So I think, to me, like, that's the number one benefit in terms of just being able to reduce the demands on our workforce. Because I think one thing that folks always think about, are like, oh, well, is this going to eliminate jobs? I'm like, no. I think if you guys have looked, there is a massive demand once again for electricians, linemen, and other trade positions, welders, etc. And those jobs are not going anywhere, and our build out is not going to stop. So anything that we can do to help increase the throughput and capacity of those folks, I think is going to be key. And that's why I think the drone inspections, and probably to a certain extent too, like just some of the sensors when it comes to like outage notifications and identification. So like you can have a circuit that's like 60 miles long, and you don't want to have to drive the whole circuit to go find where the line broke. So the more sensors that you have to be able to identify exactly, okay, this is where the outage occurs, the faster that you're going to be able to fix it, and the faster that that troubleman's going to get back to being able to do something else, whether it be preventative work or other work that they need to do. The other question, I think, when it comes to like the data centers, do they expect us to do anything different? I don't think like they necessarily expect us to use AI, but I think they expect us to make sure that we're optimizing their design to the best that we can, and that it's going to be highly reliable. So to the extent that we can use design tools that are aided by AI to inform their designs and any of our customers' designs, I think that's welcome. But I think bottom line is just make sure that you have reliable power that's going to be up 100% of the time.
Yeah, so I agree with you there. And I think on the previous question, I would summarize, and tell me if you agree with this, that you're looking for applications of AI that will free up valuable resources, human resources, if you will, craft labor in particular, that will allow you to continue to make the modifications on the system that AI identifies, and build the system for the future with all these new loads. So it's like AI is going to do things, and this would be the priority for artificial intelligence. It's going to do the things that's going to free up the manual craft labor to be able to impact the system. Is that a good synopsis of that?
Yep. No, it is. It's a really good synopsis.
Okay. Yeah, I like that point, Shawn. Good job.
All right. Thanks, Mike. So I think the last part that we can briefly go through here, right, is just so it's just really on the point of resiliency, right? So I think that since we've gone down this path, right, of working on system hardening and undergrounding, and just to clarify what hardening is, right, it's really you're looking at using like insulated conductor, and you're looking at higher class poles and composite cross arms, just to provide some context there. But As we've gone through this, we've seen like the results really speak for themselves, right? So we've had stellar years when it came to, not having, any structures destroyed and reportable fire ignitions over 3 consecutive years. And I think that we're going to continue to hopefully build on these results by building a better, more resilient system. And I think the other thing too, right? I just want to call out before we go to questions is, we want to make sure that we're investing in a modern grid that attracts new customers and load. We want to spread that cost, across more kWh. And I think our goal is really to have a lower per unit cost for all. So we really see large benefit in having our data centers customers help reduce our monthly customer electric bills, because we're spreading that cost amongst a higher kWh with a single customer that's hopefully going to make upgrades that are going to benefit other people as well across our systems. So we really like to think about this as beneficial load growth. That's the term that our CEO uses, Patty Poppy. And I think it's a great term that really encapsulates how this investment's going to essentially pay for itself to help us create a more cycle of driving affordability. So I think, Mike, maybe I'll stop here and ask if we want to do any question and answers, and then we can go to the wrap up slide once we're done.
Okay. So go ahead and send in your questions. Go back to this. What's Patty Poppy's new philosophy? It's called beneficial load growth. Is that what you said?
Yeah, beneficial load growth. I mean, really, the idea, right, is like, every 1 gigawatt from new data center demand, we think that it's going to reduce our customer electricity bills by 1 to 2%, because we're essentially making upgrades that are also going to benefit other customers, using some of that investment that's coming from our data center partners to help drive those upgrades.
Okay, but you said that you're also trying to define affordability as 0 to 3% inflation rate, or at the current published inflation rate or less. So you acknowledge that the cost of a kilowatt hour will go up at less than the rate of inflation, but the bill could theoretically go down.
Yes, that's the goal. That's the goal. Yeah, that's the goal.
Could go up, but the bill could go down.
Yes, that's the goal. And this year, actually, we've actually been able to reduce our rates like several times, just based on our rate cases. So I think that we're trending in the right direction.
That's fascinating. That's a noble goal, and I think it's going to be a tough one to achieve. But I think utilities across America are trying to figure out that very thing as well. Okay, so here's a question from the audience. I have a question regarding PG&E's use of AI-powered cameras. Are these systems deployed only at substations, or are they used along the distribution network in particular for wildfire monitoring in particular?
Great question. So we would like to deploy more along the distribution system, but as you can imagine, there's like privacy concerns with that. So a lot of our cameras are really, I would call them as like wide view cameras. So they're really just looking for, conditions changing to look to see if there's like an ignition that's, about to happen near one of our assets. And most of the cameras, right, that are going to be looking at like a very particular asset are going to be, yes, most likely in the substation, just because it's a confined space and there's no privacy issues. So that's like one of the biggest things that we have to figure out how to overcome, right, is like, how can you monitor the system with cameras, but also like make sure that like, you're not looking into someone's backyard. So I think that's one of the challenges that, we're working through as an industry at the moment with that.
Right. Well, I guess your other options is satellite, which that's pretty.
Yeah, I mean, I think
the privacy conversation, right?
Yeah, I mean, I think for the satellite, right? I mean, there's definitely like a lot of edge management applications that we've used with satellite imagery and trying to look for overhanging trees on our lines. So but that's only one dimension, right? When it comes to being able to monitor the system from the top, but it's really like can we see pole to pole, right? I mean, that would be ideal, but there's challenges that have to be overcome with that as well.
Yeah. Here's a little bit of a tangential question for you on power quality from a large Western IOU. And the question is PG&E doing anything about increasing power quality as the new loads become more sensitive? So some of these more complex loads perhaps may be more sensitive to power quality. You probably have a power quality department at PG&E, but is there anything that comes to the top of your mind, Shawn?
Yeah, I mean, we definitely do have a power quality group, and they definitely, do investigations when it comes to power quality issues, and we're constantly looking at, making sure that we're managing our expectations that we have to provide to our customers when it comes from a voltage regulation perspective. So, definitely always looking at opportunities to do more voltage regulation, but yeah, I mean, certainly, obviously, for the customers that need it, right, we're going to work with them to make sure that we're designing the equipment and the infrastructure to support them that meets their power quality needs. So that will continue to be a focus.
Okay. Here's the last question I've got from the audience, and this is, how is PG&E considering adding more visibility to end-of-line areas where SCADA or other enabled devices haven't traditionally been used? So you're pushing out to the end of a remote distribution line. What kind of things are you looking at for visibility there?
Yeah, I mean, I think, definitely, like I mentioned, there's a lot of interest in putting, sensors on top of the distribution poles, like particularly to look for, um, you know, deviation in the sense of like, looking for vibrations, looking for, um, you know, line breakage when it comes to like having current sensors. So, I mean, I think that we're doing our best in terms of just trying to place as many sensors as we can in the right places to help us with like outage segmentation or monitoring our current or other issues at the end of the line. So that's basically our approach. It's still just putting sensors as many places as we can to better understand how the system's operating.
Okay. So I'll just give you a heads up before you move to your last slide here, and then we'll get into some discussion. There's a couple things I want to discuss. The IEEE Power and Energy Society Expo that's coming up in Chicago. I'd like to talk about that. We're going to be on a panel together at the T&D Live in Orlando coming up in September. We just got notified of that, so that's exciting. I want to chat about that a little bit. And then any other things that maybe are on your mind about this whole concept of sustainability, reliability, and affordability, maybe as you wrap up with some concluding thoughts. But let's go to your next slide, and we'll chat about that, and then we'll get we'll have a little conversation.
Yeah, definitely. So I think the thing that I wanted to make sure everyone takes away with, right, is think about the total cost of ownership, think about the life cycle, think about the benefits from AI when it comes to affordability. Think about how safety and affordability sort of reinforce each other. So these are not necessarily competing priorities. If we build a safer grid, one that has less outages and one that has less ignitions that emanate from it or other issues, that's going to improve our bottom line as well and be a smart investment. And growth is going to be great for the utility industry. It's really what's going to drive us in terms of affordability. So the more that we grow, the better it's going to be for our customers in terms of having more load on the system and making energy cheaper per unit for everyone. So I think that was really the messages that I wanted people to leave with today.
Yeah, I think that I'm glad you mentioned safety, because I think this could have been titled Safety, Reliability, and Affordability on the electric grid. But we chose sustainability. We don't want to ever discount safety, obviously, but there are a lot of things where safety and affordability complement one another, and we need to be a little bit more resolute about that. Okay, let's shift to the IEEE. You and I are going to see each other in Chicago coming up here on May 4th through the 7th. Why, Shawn, why are you going to Chicago?
Well, I mean, I think the IEEE conference is a great opportunity to, obviously meet with many vendors, really listen to a lot of great panels that, Mike, I think you're going to be doing some. So we'll definitely be listening to those and really help hear from thought leaders. And then I think also great to just, meet with other utilities while we're there. So we plan to meet with ComEd while we're in Chicago and learn from them about some of their best practices, and I look forward to meeting many of you there that are going to be attending. So if you're going to be attending, shoot me a line. You can find me on LinkedIn or reach out and we'll chat and try to see if we can meet up. But I think IEEE is a great organization, and tremendous wealth of knowledge is going to be had that week in Chicago.
Yeah. One of the things that ComEd does is they've got a superconductor pilot, or maybe that's actually installed, and they're going to have a special educational time on their superconductors. So I'm going to take a look at that, and writing a paper right now on this particular topic, and I think superconductors is something that we need a position for in the future. Back to the concept of how do we position for those opportunities in the future, and I think, we're just a press release away from a superconductor that really works and works at scale, and then, okay, well, where are we going to put that? Well, we're going to put it in an underground conduit, to be sure. So, okay, Shawn, we are heading for the T&D Live as well, coming up in Orlando on September 1st through 3rd. We just got notified that we're going to be doing a panel together. So what do you expect to see out in Orlando at the end of the summer?
Yeah, I mean, I think similar things, right? We're definitely going to be meeting with a lot of our industry partners and other utilities and continuing to talk about, the topics of reliability and resilience. And, I think I will be on a panel there talking about emerging technologies that's going to be building an affordable grid. So be there with a couple folks from Southern Company and SC and other few other utilities. So I'm looking forward to joining many of you there as well.
Yeah, that's going to be a great panel. So, okay, well, outstanding topic today. A very, very timely topic for our industry. PG&E has demonstrated some great leadership, as you have in the past few years in particular, when you stated that you're going to rebuild your company from the underground up and made this commitment to spend a massive amount of money, billions of dollars on going underground with your traditionally overhead system. So give us some concluding remarks, Shawn, if you would, and then we'll get ready to wrap up.
Yeah, no, I mean, like I said, I think we're in a really interesting point in the utility industry. I mean, I think that we're seeing a lot of convergence between energy and technology, and we're seeing a changing workforce. We're seeing new demands placed on the system. So I think it's going to be a great opportunity for folks that want to solve these problems and want to keep looking at ways that we're going to be able to increase our growth, but also reduce our customer costs. And I think it's one of those things where it's going to take everyone, right? So it's not just the utilities, but it's the partners, it's the regulators, it's our policymakers. So it's going to require a group effort to meet these challenges. But I'm confident that we can, as a country and a nation, do this. And I think that we're going to be in good shape in a couple years, I hope, once we continue down this path. So.
Well, we will achieve this because it's guys like you, Shawn, that are leading the way. It's this next generation of men and women that are going to be the leadership of the industry in the years to come, in the next generation, if you will. So, hey, one thing, and I'm going to just diverge here real quickly because it's a cool question from EPRI about direct current. Are you guys looking at, is PG&E, just very quickly, are you looking at DC as an option for any kind of applications for maybe long distance transmission or any kind of DC applications, even a distribution?
Not that I'm aware of for distribution. I mean, I think for transmission, there's a couple DC ties inside of California that are running around. So I think it will be continued to look into depending on the needs, right? And there's a lot of competitive transmission inside of the state, looking at different load centers that need to be supported. So I think it'll be part of the mix, definitely, of the solutions.
Yeah. So that got thrown in just right at the very end, but I do recall this had to be at least 10 years ago that there was a large Midwestern utility that was dabbling with the idea of maybe building a DC demonstration house, basically saying that, we're going to have rooftop solar and we're going to have, these kinds of loads that we convert to AC. So why don't we just take them, directly? And oh, by the way, many of our appliances, like computers and phones and such, are direct current. So nothing ever came of that, but there was a little bit of dabbling with that. So perhaps some research. Maybe Shawn, this is one of these things that we're going to read a press release about in the years to come that will be a generational change for us. So, hey, Shawn Adderly, thank you so much for today on behalf of the Power Delivery Intelligence Initiative. We really appreciate PG&E making you available and some of the rich content that you provided and the leadership that you and your utility are showing the industry. I look forward to seeing you in Chicago. I look forward to seeing you in Orlando for the T&D Live in September, and I wish you all the very best with your young and growing family. And with that, Nikki Chandler, I'm going to turn it back to you and let you wrap it up for the day. Thank you very much.
Yeah. Thank you so much, Mike. Appreciate the session today. It was great, practical, and I appreciate your thoughts, Shawn and Mike, on the future. I agree with you on that. And I look forward to seeing you guys as well. We'll have T&D staff out at both of those events. So once again, we've run out of time. Thanks to PDI Squared for sponsoring the session. And of course, thank you all for joining. Have a great rest of your day.